Hi, welcome to my review for our quiz here, and this is number one. So this did not print. So it's some number divided by -3 is less than or equal to -7. We have to use the inverse operation, and we have to multiply -7 times -3. -7 times -3 is positive 21, and we have D. Okay, since I multiplied by a -3, this is what matters. I know they're both negative, but it's this one right here, that -3. Since I multiplied by -3, I have to switch the direction of the inequality. It's opening to the right. Now it has to be open to the left. And that is my answer right there. Simple. Number two is this one. Inverse operations. Once again, I have to, since I am subtracting 2.5, I have to add 2.5 to both sides of the inequality. And let's see, let me see if I can zoom in here. I'm not sure if I can. Nope, can't zoom in during this time. But I have this. So this is going to be C is less than or equal to 2.5 plus 2.5 is 5. And that's going to be it. So in here, it's going to be C is less than or equal to 5. Easy. All right, there's the first two. Number three is this. And I'm going to rewrite this over here to give myself more room. 18 is greater than or equal to -9 times some number. We're calling it B. Now, the variable is on the right-hand side of the inequality this time. So I'm going to, since that's multiplication, I'm going to divide by -9. These will cancel, and I'm left with B, which is what I'm trying to do right there. And 18, also divided by -9. Now, since I'm dividing by that negative right there, once again, I have to switch the direction of the inequality. 18 divided by -9, that is -2. Great. Now, I could enter that probably in my answer, or I could write B, and it's open to the B, so I'm going to keep it open to the B, and -2 right there. So both of these say the exact same thing. And I kept the inequality switch. See, it was open away from the B here. Now it's open towards the B, and it's still open towards the B. So I imagine you could probably enter either answer, and it should be right. Next, number 4. Jose has scored 544 points on this math test so far. To get an A for the semester, he must score at least 640 points. Write and solve an inequality to find the minimum number of points he must score on the remaining tests. We're calling that N in order to get an A. Well, if we start with the 544 plus whatever his score needs to be, and that needs to be at least 640. So that means this has to be greater than 640, but he could also score exactly 640, so greater than or equal to. That is our inequality right here. Now to solve the solution, so that goes right there. The solution would be 544 plus n is greater than or equal to 640, and we have to subtract 544. And these cancel each other out. N is greater than or equal to, let's see, that's 6, and this is, 9? 96? Let me check to make sure. So that means 544 plus 96. No, I'm wrong. Oh, wait, no. 0, 1. Okay, that is 14, 640. Okay, I'm right. Haha. And so that means the solution is n is greater than or equal to 96. And next, number 5. During a scuba dive, Lainey descended 25 feet below the surface of the ocean. She continued her descent at a rate of 20 feet per minute. Write an inequality that you could solve to find the number of minutes she can continue to descend if she does not want to reach more than 125 feet below the ocean's surface. So she descended. So she is 25 feet below the surface of the ocean, and so that's -25. That's represented by the number 25, -25. So, and then she continues to descend. So she continues to go down at 20 feet. So she's going down minus 20 feet per minute. And per, that's telling me to multiply by the time right there. Okay. Now, we're comparing that to 125. Oh, below the ocean surface, so that's negative 125. And she doesn't want to go past that point, which means that has to be a higher elevation. So that means this has to be greater than, but it could be equal to, because she can get to 125, but she doesn't want to go past it. And so that has to be higher or a greater value. And that is the inequality that we're asked to put in. Number 6, a two-step inequality. And there's a little division sign right there that didn't print. This is subtracting 8, so I have to add 8 to both sides of the inequality. And I'm going to, let's see, d over. Now, that negative can go anywhere. I'm going to prefer to put it in the denominator. And here's less than, and 8 plus 1 is 9. I'm going to rewrite this over here. D over negative 11 is less than 9. And finally, I just have to multiply these two. And keep in mind, I'm multiplying by a negative. So I have to switch the direction of the inequality. And negative 11 times 9 is negative 99. That is the solution. That's what you would put in your box right there. And let's see, there's 5. Okay, so that's question 6 and question 7 right here. All right, we got to solve this. Not so bad. I'm going to write this up here. Negative 7w minus 16 greater than or equal to negative 72. I am going to first get rid of the subtracting 16 by adding 16. Inverse operations. Negative 7w is greater than or equal to, I got to subtract 72 minus. So these are opposite signs. I have to subtract them. I know that my answer is negative, or this part of the answer is negative. And 12 minus 6 is 6, and that is 6 minus 1 is 5. Negative 56. My next step, since that's multiplication, I have to divide by negative 7 on both sides. These cancel. I'm left with w. I divided by a negative right there. That's super important. Once again, I have to switch the direction of the inequality in that. And negative divided by negative is positive, so I know my answer is positive. I'm not going to write a positive sign there. But 56 divided by 7 is 8. This is the solution. That is what you would put in that little box right there. Number 8. Okay. Number 8. Wow, John says that if one side of the inequality is 0, you don't have to reverse the inequality symbol when you multiply or divide both sides by a negative number. Okay. Well, let's see. If you divide both sides by negative 7, so let me rewrite this here. Negative 6z is greater than or equal to 0. So if you divide both sides by negative 6, so you divide both sides by negative 6, this is z. Z is greater than or equal to 0 divided by any number is 0. So this would be 0 right there. Okay, now they're saying that's wrong because if you choose a value, and so they're trying to disprove this statement up here by going through the steps here and not switching the inequality. So we should know that we do have to switch the inequality symbol because we're dividing by a negative. But they're not in this case. And so we're disproving it. Okay, fine. If you choose a number such as z is equal to 3, and they're choosing 3 because it's bigger, see, z any number greater than 0 would work according to this wrong solution, and 3 is bigger than 0. So substitute 3 into our original inequality. So our original inequality was 6 times z is greater than or equal to 0. And so negative 6 times 3, putting that in for z, is that greater than or equal to 0? We should get a false statement here. Oh, I'm sorry. That's 3, so it should be a positive 3. Negative 6 times 3 is negative 18, and that is false. So that didn't work. And it shouldn't work because we did the problem wrong here. So into the original equation. Okay, got that. I just did that. You get what? Negative 18. Negative 18 is greater than 0, which is false. All right. Now we have number 9. Number 9, complete this. So let's see. We're trying to use this and make an inequality out of that. So Mr. Craig is buying pizzas for a 7th grade field trip. He can spend, at most $17. See, that's $17. That's his highest value that he could spend. And needs, he's going to need 6 pizzas. And he has a $19 coupon. See, that coupon we can subtract from the price, the cost of all those pizzas. See, that's quite nice. How much can he spend per pizza? And that's the X. So Mr. Craig can buy pizzas that cost at most. Okay, so let's see. I have to now solve it. 6x minus 19 is less than or equal to 17. I have to add 19. 6x is less than or equal to, that's 6, that's 36. And I have to divide by 6. Less than or equal to 6. So that's the number of pizzas he could buy. He could buy at most $6. He could spend at most, buy pizzas that cost at most $6 per pizza. Okay. And finally, number 10. Our compound inequality. It consists of 2 simple inequalities joined by the word and or. Graph the solutions. Okay, so we're going to graph x is greater than 2. That's pretty simple. X is greater than 2 goes that way. And x is less than 9. X is less than 9 goes this way. So they're going to what are the numbers that are greater than 2 and they're also less than 9? Well, it's all these numbers here. So we just kind of join this up here, and this is it. I'll get rid of those little arrows because now we can see that it's just those numbers right there. That's all we need. This is the graph of the compound inequality of that greater than 2 and less than 9. Okay, part 2. Let's do an or now. What's less than 2? Okay, less than 2. Less than 2. Or is greater than 9. Greater than 9, right here, right there. Now, let's see now. What's less than 2 and greater than 9? Okay, let's look at part 3 here. So select the description of the solution set of the compound inequality x is less than 2 and x is greater than 9. X is less than 2 and x is greater than 9. Well, let's see. If I have 0 to 9, x is less than 2, that is this. X is greater than 9. Oh yeah, that was the one I just did. Hello. There's no number. And it has to be smaller than 2 and it has to be greater than 9. There is no number that's smaller than 2 and greater than 9. Here, there are all these numbers, but that was an and in this case. And that was or it could be or. But here, this has to be and. The numbers that are that follow both conditions, there's no such number. Oops, N-U-M-B-E-R. I can spell number. And no such number or no solution to that. And what about x is greater than 2 or it's okay, let me draw that out real quick. 0 to 9. X is greater than 2, so x is greater than 2 or x is less than 9. Okay, now in the and, we were just, what are the numbers that are greater than 2 and they're also less than 9? Well, it's just that. But here, actually, this will go beyond. And so it's all numbers. And so, if they're all numbers, let me explain that here. It has to be bigger than 2, and the numbers bigger than 2, they go way beyond 9. They go way over there. And the numbers less than 9, they go beyond the 2. They go way that way. So what do we have left? We have every single number that's possible here. So it's all numbers are the solution for that one. All right, that's what you got to know for this test. Thanks for watching.